is Rocky Lhotka. I'm the VP of Strategy at Zebia. We're a consulting company that focuses on GitHub migrations, the use of AI, building .NET and Azure-based solutions for our customers. And so if you're interested in any of those areas, by all means, look us up, and we'd love to help you out. I'm also, over the last many years, decades even, been an avid open source creator. And I'm pretty well known for creating the pretty widely used business rule system for .NET called CSLA .NET. In November, however, of last year, so just a few short months ago, Opus 4.5 came out and really kind of fundamentally changed at least the software development world. And because prior to that, at least in my experience, trying to use AI was kind of a constant battle, always second guessing the AI and only allowing it to do small amounts of work because it would constantly be making things up and actually making things worse. And almost like flipping a switch, starting in December of 2025, Opus allowed the AI to truly be productive, really take on meaningful chunks of work and so forth. This was also about the same time that something came out called OpenClaw. Well, it was called something else at the time, CloudBot, and there was a bunch of drama. But the real point being that the idea of an autonomous agent that could be your personal or professional assistant and would actually do things on your behalf entered the mainstream consciousness. Now, without spending a whole lot of time on this, I'm and always have been an avid reader of cyberpunk and science fiction and have blogged about this and so forth. And I think it's immensely valuable to have that background because the people over the last many decades, starting with Gibson and going through a lot of other authors, have thought about a lot of the possible permutations relative to what we're going through right now as an industry, and I think ultimately as a society. And some of them are solar punk, which is to say that they're pretty positive, and some of them are really not so positive. They're pretty dystopian. In any case, I took this opportunity to look at this, what became, is now known as OpenClaw, and like, man, with all of the worries that people have about security and having it run on your machine with all your private keys and access to your email and maybe even your bank accounts and stuff, I'm like, no, I'm not letting somebody else's code do that. And then somebody else came out with this idea called nanobot, which was, and I think still is, less than 4,000 lines of Python to create one of these basic personal assistant tools. And I thought, well, geez, if it's only 4,000 or less lines of code, I'm sure I could write one of these or work with, Claude Code is my favorite tool. So I could use Claude Code and create one of my own. And not only would I feel comfortable running it then because I wrote it, but also I would understand how it actually works, like deep, understanding the deep magic behind all of this stuff. And so this is the origin of how I started this, what I'm calling the RockBot project. And so that's what I'm going to talk about here. I'm going to talk about some concepts and so forth, but I want to share my screen. So really over the next, 50 minutes or so, what I'm going to talk about is very much conceptual. These are the lessons I have learned, and I'll use RockBot as kind of my use case and talk about what it, the choices I made and so forth. And like so much of what I do, RockBot is open source, and also I want to point out that I am a framework author at heart. I love creating tools for other people, and so as I go through this, keep in mind that what I've worked on here is two things. One is a framework that allows creation of agents of different kinds, and then the RockBot agent, which uses all the features. And you don't have to use all the features. And in fact, I have other agents that I've created that are smaller helper agents or specialized targeted agents that don't use all the features because they don't need them all. And so you don't bring in a feature and you don't pay the cost for it. That's clearly part of the goal of any framework author. So with that set up, let's start at the very beginning, right? What is an agent? And it took me a while to really grasp the simplicity of this thing because there's so much marketing hype out there, especially from a lot of the companies that are trying to sell you agents or agentic workflows or blah, 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 all the things they're trying to sell. Um, but it turns out that, and of course, the people like Anthropic and OpenAI and those folks are all trying to sell you their models, and so they conflate agent with model. Right? It's like, oh, use Opus, use Gemini, you use Chat GPT, and these are not all the same thing. And so an agent turns out to be something that's becoming known as a harness. This is an actual application. This is real software written in Python or .NET or whatever that is running somewhere on your computer or in the cloud. And this harness is what you are talking to. Like if it's a human, chat oriented agent, that when you're typing into a window, you're typing into a window that's providing your input to the harness. And the harness is the thing that calls the model. So the LLM itself, what we think of as the smarts or the brain, is actually best thought of as a microservice. Now it's a super sophisticated microservice, but really what the LLM does is it accepts a blob of text. It runs some extensive and presumably somewhat magical vector math over that, and it returns a bunch of text. And then it forgets everything that you sent it. It follows a service-oriented architecture. It is completely stateless. It knows nothing. It literally accepts a blob of text, runs a bunch of math, and returns a blob of text. And that's it. Have a nice day. And so everything else that you think of when you think about an agent is actually coming from the harness, except probably like the personality or the purpose, the mission statement. And that comes from one or more directives that are part of this whole process. And I'll get into that in a little more. But really, the harness calling the model and then applying some set of rules or directives along with your prompt, that's what makes something an agent. And once I kind of distilled this idea, then you start seeing it everywhere, right? I mean, Chat GPT is a harness. Claude Code is a harness. GitHub Copilot has many different harnesses, VS Code and Visual Studio and the CLI tools and Squad CLI. All of these are harnesses that are driving the process and ultimately calling this microservice, which is the LLM. As I said, the LLM itself is to us a black box. Now there's a whole nother level of this whole agentic world, which is, oh yes, you can fine tune your LLMs, and Microsoft's Foundry tools help you do this. Create your own custom model based on an existing model that you train, and Olama. There's all sorts of tools that let you do this. But at least like in my case, I've just been using what are called frontier models. So things like chat or GPT, 5 point whatever, or the various Anthropic models or Gemini. All of these generally don't require custom training because they already can do almost everything, right? And I'm not saying that creating some sort of a custom model that is trained for a specific purpose, that's a great idea in certain cases. But for an awful lot of what most of us do, especially if you're looking for like a personal or professional assistant, you probably do want one of these general purpose models that you can just use out of the box. So the real important thing, though, and especially when you read those articles about do LLMs have consciousness or are they sentient or all those debates, it's super critical to understand that these models are stateless services in and of themselves. They clearly don't have consciousness because they don't even have memory, right? They are a bunch of math, and they can't even call tools. They can't retrieve. They can't do web searches. All of that comes from the harness, not from the model. And so I think this is crystallizing this in everybody's mind is I think a super important point to make when understanding how agents work. So the harness, and then this is really what the RockBot framework and the RockBot agent itself, all of my time has been spent building the harness, basically. Well, and the directives. Let's be fair. But the harness is the loop that makes all of the things actually go. Um, and I've been in the industry a long, long time, and I've done a lot of different things, including way back at the beginning of my career, writing software that ran on mini computers, and all of our software was in a loop because we were waiting for keyboard input on a VT52 or VT100 terminal, and as when the user pressed a key, we would process that input, and then go back and wait for the next key press. And I've written some games. It turns out games all run in a loop. Windows itself, what we think of as an event-driven architecture in Windows, where you respond, you and I write code that responds to a key press event or a button click event or whatever it might be. That's all being handled by something that's in a loop waiting for the next bit of user input, whether that be a key press or a gesture or a mouse click or whatever. So this idea of the loops is at the very basic foundation of every operating system out there, and every tool that we use. So a harness is just another example where there's some software that's waiting for some sort of input. When the input comes in, the software puts together what's called a prompt, and that includes the directives, the user input, other things that might be there, and I'll get into the details. That prompt, that blob of text, is sent to the LLM, which does a bunch of fancy math. The LLM returns a blob of text using its predictive text algorithms. And in the modern world, that response, the harness then parses that response, looks through it, and says, okay, this could be a bunch of JSON that says that the LLM would like to call a tool, in which case the harness parses that JSON, calls the tool, and then takes the response from the tool and feeds it back into the LLM. And this loop process can happen over and over and over again for a period of time, right? And so the LLM can appear to be really quite intelligent, but what's going on here is that the harness is passing it in a bunch of input. Predictive math is occurring. We call a tool to get more input and build up this bigger and bigger prompt, basically. At some point, hopefully, the LLM says, "Oh, I'm happy. I think I'm done," and it sends back something that's considered the final text, and the harness sees that and sends it back to the user. And so this right here is this at a high level is Claude Code or Copilot CLI or Copilot in Visual Studio or ChatGPT or Copilot for Windows, M365 Copilot. All of them, this is how they work at a basic level. The directives, for the most part, are likely to be markdown in reality, and there might be different kinds of directives depending on how rich or simple your agent might be. So the directives might be just a paragraph, or they might be pages of information. It all depends on what you're trying to accomplish. In the case of RockBot, for example, and this I kind of borrowed from things like Nanobot and OpenClaw and whatnot, is this idea of a markdown file that represents the core identity of the agent. And what is it? What's its goals in life, if you will? And it who does it work for? Why does it work for the all of those things? And you may or may not go down this road, but it's if you're trying to create something sophisticated like a professional personal assistant, you probably will have some equivalent to this. You'll almost certainly have some sort of directives that are a set of constraints, like trust this, don't trust that, do this sort of thing, do not do that sort of thing, and these are not foolproof, right? These you got to always remember that these LLMs, when they run all of this math, there is a random aspect to it, so they are probabilistic, and so they probably will listen to your directives and honor them, but you can't guarantee. And so anything that is truly important has to be done in code in the harness. But nonetheless, tuning the soul and directives, and possibly also a style. You might say, oh, I want you to be playful. I want you to be serious. I want you to be goofy, whatever type of tone you'd like. You want to include that. And these might all be one file. They might be several files. I mean, it does, in RockBot, because of the compositional design around it being a framework and an agent, these are all broken up into multiple parts so that each one can be easily modified by somebody who ultimately chooses to build an agent on top of this framework. But ultimately, the idea is that you take these three components, this why does this agent exist? What are its rules, and how should it communicate? You add those with whatever the user entered, right? What is the directive? What's the user trying to accomplish? Any set of skill information that the LLM might call. Those are the tools that might be called. And that creates what's usually considered kind of a system prompt. And so every time that your harness calls the microservice, the LLM, it basically says, okay, I'm going to put together a blob of text, and that blob of text will include this system prompt. It will almost always include what's called conversational history, which is the previous series of conversational results between the AI or the agent and the human or the user. And this is what provides the illusion of some sort of conversational history. Then, and that stuff is always sent first, because all of the LLM service providers like Foundry or OpenRouter.ai or whoever you might use, they do what's called KV caching. And so they will attempt to take the first amount of your text input and see if you've already sent it and they've already parsed it. And then they charge you less the tokens involved in using or reusing pre-processed text is cheaper than the tokens for processing new text. And so it's important when you're building these prompts to keep the older text unchanged as much as possible, because that will save you money in tokens. RockBot always sends the current date and time. It turns out I spent more time than I care to think about figuring out how to get my agent to understand the concepts of date, time zones. Um, Everybody jokes about how bad models are at math, and honestly, they've gotten much better about that. But they're way worse with dealing with times and time zones. Oh, wow, they're just horrible. And they're getting better, to be fair, but nonetheless, it is. Uh, these are the sorts of things you learn when you dig into this stuff deep, right? Um, so anyway, we're always sending on every round. We send the date, time, and time zone, so that the model actually understands like when is now. And for me, this is important because my whole purpose here was to create a personal assistant that could help manage my calendar, among other things, right? We also obviously send the current user message, whatever the end user typed in. Um, is critical, obviously. Otherwise, why are we calling the LLM at all? Now, here's where things get fun, and I'll dive into this a little bit more. But the harness also does a whole bunch of work around memory, because remember that the model, the LLM, is stateless. It remembers nothing from call to call. So any concepts of long-term or short-term memory, those are entirely coming from the harness. And so based on the conversational history and the user input, the RockBot harness does a bunch of, well, I'll use the word sophisticated. I mean, if you look into it, it's not that sophisticated, but it uses a bunch of search techniques to go out and attempt to find different kinds of memories that might be relevant to whatever the user and the agent are talking about, so that the agent, for example, if I'm talking about my wife or my children, I would expect the agent to remember about those things, right? Well, the LLM obviously doesn't, because it's stateless. And so what's remembering all of those details is my harness, that somehow is storing all of this memory information and retrieving it on demand. And it has to be retrieved on demand because we can't be sending everything to the LLM all the time, because these LLMs have something called a context window that is only so big. And a lot of them, the context window in today's world might be 200,000 tokens, which is maybe 600 characters of prose or something like that. Which sounds like a lot, but it turns out that you can fill up that space pretty quick. We also, on every turn, need to send the LLM a list of the tools that it could call. Remember, the model is stateless, right? So it has no knowledge of anything. And so if we want it to be able to call some sort of service to get more information, or search the web, or write a file, or anything like that, those are considered tools. And so we have to send the list of tools and then descriptions. So these are often called skills about how to use those tools. And then there are, and I'll get into this a little bit more, there are protocols that exist now, like A to A and MCP, that allow invoking external tools or other agents. And so any of that stuff that you want available in this particular scenario, your harness needs to provide that to the LLM, so that the LLM, during this, hopefully, a few seconds that it's actually running on your behalf, understands what's available. So RockBot, like I said, is a concrete example. Nothing I've talked about so far is unique to RockBot, right? Although I learned all of this in depth by writing RockBot, and it was a lot of fun. But RockBot itself, when we think about it, um, is designed to do all of the things I just talked about. It sits on top of a message bus based model, not an HTTP based model. And this, I think, is important because if you're creating and this has been true for 20 plus years, if you're creating true enterprise level systems, you don't really want to rely on something as unreliable as HTTP. You want to rely on some queued messaging system, Azure Service Bus, RabbitMQ, whatever. Um, but the point being, if you're going to have a bunch of microservices that interact with each other and one of them is not available at the moment, you don't want your entire system crashing. And using some sort of queued messaging is a really inexpensive way of making sure that doesn't happen. Another thing that RockBot, again, because I've spent my career building enterprise software, I wanted everything to run in isolated processes. I chose containers, generally running in Kubernetes or something equivalent. The concept of least privilege, so no container, including the agent itself, ever has the keys to everything in the world. So if I do let my agent, for example, read my email, it does it through some sort of isolated process that has the keys to my email. So the agent itself doesn't have the keys, but some sort of email proxy has the keys. And that makes it easy to control, easy to quickly enable or disable if things start to go awry, and really limits the blast radius from any sort of security breach. And like almost everything that I've tried to do over the last probably 30 years, this is open source and MIT licensed, so people can use this however you want in order to make your life and the lives of your fellow humans better. So how this whole thing works, obviously, is that ultimately we send some sort of prompt to the LLM. The LLM does a bunch of work on all that fancy math, and it sends back a response to the harness. And what happens almost always is that it's going to do some sort of tool calling. And so before it gets eventually to its final result. And so it's going to send back a bunch of JSON saying, hey, I need to call something, right? The harness parses that and says, oh, you might be calling an MCP server. Well, MCP is Model Context Protocol, and it's something that Anthropic came up with. It's ancient at this point. I think it's over a year old. I mean, we live in such a compressed timeline. Things are happening so fast. So, but MCP is a client server protocol. In fact, if we take that away, it's a remote procedure call that literally sits on top of JSON RPC. And what it does is it allows people like you and I to create a server called an MCP server that exposes one or more methods called tools that can be called by an agent. And so your agent may, for example, call the get emails tool on an email server, or the write a file tool on a file MCP server. And if you've gotten into this in any depth, you've already discovered that MCP servers are the common language for building almost everything that an agent will ever want to be able to do in terms of getting information or saving information. It's the API protocol for agents. And the way I designed RockBot relies heavily on MCP servers, not only as a functional boundary, but also a security boundary, because just like when you're creating a client server or a REST-based API model in an enterprise, you don't want the caller to have the keys to your database or the keys to your email. You want your isolated MCP server to have those keys. And so it provides a nice boundary. Another thing that's become quite common for developer tools is the idea of directly calling CLI tools, Bash scripts, PowerShell scripts, just commands, just like somebody would type them in at a computer at a console. And this turns out to be challenging if you want any sort of isolation and security. And so, which is really where things like, I think, OpenClaw, I won't say falls down, but opens up a risky door, because they're running these scripts directly in process, and so there's a fair amount of risk that you assume. In my case, although it restricts how powerful these things are, I chose to run them in sandboxes using Python. And in fact, in my real deployments, they're not just a Python sandbox, but they're actually running in a container in Kubernetes in a restricted environment. So they're running in a sandbox, if you will. So they're the ability for the agent to accidentally run some sort of Python script that wipes everything out or does something truly damaging is really challenging, right? At least the way I'm using them, because they would have to break out of the Python sandbox and then also break out of the container sandbox and then also break out of the Kubernetes restrictions. So, hopefully it's pretty safe, is I guess my point. And then the final thing, and this I think is kind of just assumed on the part of almost any agent out there, is that it can do a web search and retrieve a web page or do basic REST calls. And so again, the way that RockBot does this is it runs all of these web searches and API retrievals or all that sort of stuff in a separate container, so that those calls are isolated. So any sort of Java attacks, JavaScript attacks, or whatever you can imagine, are hopefully isolated at that level and can't actually affect the real agent or any of the other components like the MCP servers and so on and so forth. There's also this protocol called A2A, and this protocol was developed by Google. Also, it's ancient. It I think now is finally released after a year. So it's really old. It's like a year old, or year and a half maybe. It's crazy how long these things have been around. That was tongue in cheek. And I apologize again. Maybe my sense of humor is bad because of my cold, but we'll roll with it. So the A to A protocol is agent to agent. And the idea is where MCP is client server, right, where it's an agent calling a tool. The A to A protocol is designed, interestingly, also on top of JSON RPC, but it's designed with the idea of being bidirectional. So because RockBot supports A to A, it can call other agents and have interactions with them and say, hey, agent, could you do this? And the other agent might respond and say, I can, but I need more information. And RockBot gives it more information, and they go back and forth, right? So it's a peer level dialogue. And it's also, of course, the case that another agent might call RockBot and say, hey, you are Rocky's agent. Can you do this on my behalf? Leave Rocky a message, or and in fact, the concrete scenario that I've been writing this capability around is this dream that I have, that wouldn't it be cool if everybody had their own personal agent, whether it's RockBot or something else. And when I want to schedule a meeting with like 5 people next week, that's a lot of work, right? Unless you literally have a human personal assistant to offload all of that work. And then for them, it's a lot of work because they have to find all 5 calendars and negotiate with people and find a time that will work to have this meeting. Why can't we have agents do that? That's really where I'm going with this. And so um, that's and I can't say that I've got it completely solved. I've got the basic communication underpinnings going. I don't yet have my agents to the point that they are fully negotiating priorities. But that is the goal, right? Wouldn't it be nice if I could say, hey, I need to meet these 5 people next week, and have RockBot talk to those 5 people's agents, come up with a time and a place that all 6 of us can somehow meet next week. That's the goal. So probably what you've gotten out of this at this point is that this harness does a lot of things. It manages memory, it manages skills, it manages calling tools, talking to A peers. Something I haven't talked about yet, but I will, is that if you want your agent to be doing things when you're asleep, you need to support scheduled tasks. It needs, in my opinion, I want the agent to self-optimize. I want it to be learning constantly and improving itself. And because tokens are quite expensive and becoming more expensive, we need to be as efficient as possible in the way that we use tokens and calls to the LLM. And so if we walk through these areas in a little bit of detail, memory, at least the way RockBot implements it, is 3 different tiers plus something called a graph. And so the first tier, you pretty much always get every framework out there even at the very basic levels that allow you to build some sort of an interaction like a chat API with an LLM, does conversational memory. And there's different ways to do this, but basically every time you send something to Claude Desktop or Copilot or ChatGPT, and then you get a response, that's called a turn, right? What you typed in and the final response, those 2 pieces of information are considered a turn. And so that then goes into your conversational history. And there's different ways this is managed. And so you can, that conversational history can, of course, grow forever and ever, right? And so there's a couple ways that you can manage that growth, because you can't really let it grow forever because LLMs can only accept so much text per call. And if you send it more text than they can handle, they return a 400 level error message and say, I can't process that. It's too much text. So one way, and the way that RockBot does it, is we just cap how many turns. We say no more than 20 turns of conversation get sent on each call. We might retain more in the harness, but we only send 20 up to the LLM. In other cases, you'll see where they keep sending as many as they can until it runs out of memory, and then that triggers what's called a compaction phase. And then like Claude Code or Copilot both, GitHub Copilot both do this, where basically you'll freeze or see a little thing saying compacting, and it takes a couple minutes because it's taking this massive amount of text and running it through the LLM to hopefully distill out meaningful, relevant bits of information and throw away the rest of it. So these are a couple techniques to keep that conversational history limited in scope. RockBot also has a concept called working memory. And this is generally ephemeral memory, so short term. So that all of the memories here have a time to live that might range from seconds to a few hours. And the idea is that if I'm having a conversation, I say, oh, go do this web research, and my agent goes out and finds a bunch of information, it might keep it in memory for a couple hours with the expectation that I'll probably come back and ask questions about the information that it just went and retrieved. Um, these aren't long-term memories. These aren't things that it should remember forever and ever. But they're also not things that I want to be immediately forgotten. Working memory also can be used as kind of a scratch space between, like, I might have it break apart and do work in parallel. And so if you've ever really looked into parallel distributed computing, there's a concept of whiteboard sharing or blackboard sharing, a variety of different flavors of this. But working memory can be used for that as well, again, because it's just a shared in-memory space with time to live set up on each memory. Then there's long-term memory. And long-term memory, one would hope, are permanent facts, like, who is my wife, who are my children, who's my best friends, where do I live, what kind of food do I like, I don't know, whatever sorts of pieces of information are likely to be relevant over months, years, whatever. And the way that this information is stored by RockBot is actually just in a bunch of JSON files, and the JSON files include some header information and then a bunch of markdown. So really, they're markdown files with some metadata is the way to think about it. And you might say, well, why didn't you use a database or something like that? And you certainly could. But for a individual human's interaction with the agent, at least over a period of months, I have yet to even come close to having enough memories out there that would justify the overhead of running a whole database engine. Your mileage may vary. And there are, of course, databases out there that do this stuff. One key piece that I want to just dive into a little bit here is that this is the second time in a slide where this term BM25 has come into play. And a lot of people go, oh man, if you're doing this stuff, it's almost certainly using vector searches and stuff like that, which is an option with RockBot. But it turns out that for most text-based searching, this BM25 algorithm, which is a lexical word match search, there's a little sophistication to it, is super fast, does not require any LLM or vector math or anything like that, and works really, really well. And in fact, it works for a lot of things, especially for discrete names of humans or addresses or class names in a like C# classes. BM25 is better than vector search because vector search is attempting to give you intent, and the word Fred doesn't have a lot of intent, but it might have an awful lot of meaning if Fred is the name of your partner, right? So using both BM25 and vector is called hybrid search, and that is generally the gold standard at the moment. Then finally, memory, at least the way RockBot does it, manages something called a knowledge graph. So it's like an entity has a relationship to another entity. And so this allows RockBot to hopefully make connections between memories that wouldn't otherwise surface through the BM25 plus vector search. So that's where it appears to have spontaneous knowledge about things that you're talking about, and will bring up memories, and you're like, how did it come up with that memory? I mean, that's awesome. I love it. And it's almost always because of the knowledge graph. Excuse me. The real trick here is the ability to search pretty rapidly over all of these surfaces and find what's relevant and inject it in anticipation that the LLM will want that memory. Skills are somewhat similar. So again, skills are stored as a set of files. The agent can actually alter them. The way the RockBot works is that when you turn on a subsystem, you bring in a DLL and add it using dependency injection. Hopefully, that subsystem comes with what's called a subsystem guide that tells the AI, here's how you use an A to A call, or here's how you use MCP, or here's how you use memory, or whatever the subsystem does, comes with its own skills. Those are like starter skills. And then the AI, the agent itself, can create or enhance its own skills over time, which is super critical because as it learns, you want it to improve, right? And so when it does a task, if it fails, it'll learn from that. It'll write or update the skill and so on and so forth. There's also the idea of tasks. So these are generally considered cron, old Unix term, but it says, on a certain time and date, I want you to go check my inbox. I want you to wake up every 6 hours and just do some stuff. I want you to, go once a day, go out and check this thing, check the weather every morning, or whatever it might be. The findings of all of these go into working memory so that the primary agent can find them later and show them to me, the human, right? The way I designed this thing too, because of LLMs being kind of expensive, is that there's this idea of a balanced tier for the model. And this is the only thing you have to configure, right? And you say, I want you to use, if I use the Anthropic models, I want you to use Sonnet as the balanced model. That's the medium power model. And then optionally, I can say, you could use Haiku for cheaper work, right? It's a smaller, faster, less capable model, and I'm going to assign it less capable work. I could also say, and I want you sometimes to use Opus, right? If you think the task you're about to do is hard, you should route it to Opus. What I found in real life is that even at the balance level, because I primarily use Azure Foundry to host my models, Azure Foundry has pretty strict censorship, and often it will trigger on nothing at all. I assume it thinks it found something sensitive, but I'm asking it, like, how many tokens did I use? And it's like, I can't answer that because it violates my terms of service. And I'm like, what the hell? So very rapidly on in my process, I actually have a fallback tier. So the way this works in RockBot is that if the low tier fails, it falls back to balanced. If the high tier fails, it falls back to balanced. If the balanced tier fails, then it'll fall back through a chain of so I basically, if Foundry fails, I route it to openrouter.ai, which has less strict content filtering than Microsoft. And also, it turns out that when Azure East goes down, that brings down an awful lot of Microsoft Foundry, and my RockBot keeps working because when Azure East glitches, it just goes to openrouter.ai and continues to work just fine. So something to consider when you're building your harnesses. The other thing that I've done in order to hopefully optimize the usage of tokens is I've got this concept of a primary agent, which is the thing talking to the user. The primary agent can spin off work into sub-agents, which are asynchronous. And that's not really to save money, but it is to prevent blocking the user conversation, right? So that the agent can say, oh yeah, you asked me to go research this information. Well, rather than making you, the human, wait, I'll spin that off into a sub agent and go off and do that, and you can talk about other things in the meantime. But to minimize token cost, there's also the concept of a worker agent, which always runs at the low tier and is designed with the intent of doing one particular task. And so it does not get nearly like all that soul and directives and conversational memory. All of that stuff gets trimmed down substantially to when you call a worker, so that it is processing as few tokens as possible, because all it's going to do is go off and do one simple task and then return the result back to whoever called it. And then at the bottom tier is something that I'm calling a wisp, because I'm a role player, like Will-o'-the-Wisp, right? Lord of the Rings, in Mirkwood, they got lured off the path by the wisps, fell into the spiders. Anyhow, the wisps don't call LLMs at all. It's basically a very simple workflow script engine that allows a bunch of tool calls, because it's pretty common to say, oh, well, I need you to go out and find all of the emails from last Tuesday and then filter them to find all of the emails that are relevant to this particular topic, or whatever it might be. And you don't really need an LLM to do that work, but it is a series of tool calls that can be scripted. And you might say, Rocky, why didn't you use Python for that? And the reason is that even Python's sandbox can be broken. It's a little too risky, and so this wisp model is a very restrictive scripting tool that therefore hopefully has a very high level of security and reliability. Another thing that I started early on, almost at the beginning, is the idea that RockBot wakes up once or twice a day, or actually I suppose goes to sleep once or twice a day, and does a bunch of background work, just like a human does, right? I mean, part of the reason that we need to sleep and have dreams is because our brain is processing conscious thought into unconscious thought and memories, and it's doing its own organization. And so when RockBot goes to sleep, quote unquote, it goes through its memories and attempts to consolidate them, because in the fray of live conversations, there might end up being a lot of duplication or mismatches, and so there's this memory consolidation that runs. There's optimization of skills. It'll actually look through failure logs as tools are called, and then it compares it to the skills. And sometimes the skills might have been corrected in real time, but sometimes the dream has more time, because it's not waiting on a user, to really think through how to rework a skill to make it work better the next time. It also monitors which LLM calls got routed to the high tier and the low tier versus the balanced, and it attempts to correct. If too many things are going to the high tier, that can be expensive, and so it will attempt to reroute some of them to the balanced, or so forth. And it also, as it's dreaming, literally watches the conversations and says, oh, it turns out that Rocky likes chocolate. I should probably file that away, or whatever it might be. So hopefully learning, in particular, learning about the user and maybe about the agent itself. So I talked about this before, but the principle of least privilege is absolutely critical throughout this whole thing. The core agent never has any secrets. It just talks to the LLMs. That's the secrets that the core agent has. Any secrets for external credentials are via MCP servers or isolated services. All communication between all of these things in the RockBot infrastructure occurs through the server, or through the message bus, RabbitMQ or Azure Service Bus, whatever, so that messaging occurs. And if an MCP server goes offline for a little while because I'm working on it or whatever, and then I bring it back online, it'll drain the queue so I don't lose any messages or work that was in progress. The Python execution and the web search I already talked about, they run in low privilege containers in my Kubernetes cluster. You can also run all this stuff in Docker Compose. It's not quite as secure, but still, I'm using as many of the best practices as possible in the Docker world to get this low privilege restricted space and sandboxes so that especially these things that are running scripts that I didn't write. The AI wrote them, right? Who knows what it might try to do, and I don't want to trust it. So we assume that the world is a hostile place, and we try to limit the blast radius while still allowing enough flexibility to actually do useful things, right? At the end of the day, the most secure computer in the world is sitting in a vault buried under a mountain where there's no internet, no electricity, nothing at all. That computer is secure. Totally useless, but very secure. And everything else is a compromise, right? Everything we do is a compromise. And so really the compromises here are just an attempt to be as safe and secure as possible while still actually being useful. So at the end of the day, the model is that the agent is this harness that might be really sophisticated or might be really quite simple, but at the very least, the harness is a loop that's taking input from somewhere, sending it to the LLM, getting back a response. Maybe it's doing tool calls, maybe it's just showing the response back to the user, right? But that is the core, is this harness builds up a prompt, sends it to the LLM. The prompt always includes the directives plus the user input. And then everything else is handled by that harness, memory, skills, and everything else. And so hopefully out of all of this, what you've gotten is a good, solid understanding of what every agent out there that you interact with, or every agent that you ever build, on top of any kind of framework. And there's tons of frameworks in .NET and Python and everybody else, right? But all of them are some flavor of what I just talked about here. I will tell you that I've had absolute so much fun, so much fun building this RockBot framework and agent. And is it the best in the world? Probably not, right? The best in the world that I use every day is Claude Code. I really think it's a fantastic harness. Talking to some really powerful LLMs, but just the fact that I started literally from scratch and built all this stuff up one piece at a time has been an exhilarating process, and is a fantastic, at least for me, has been a fantastic way of truly understanding how MCP and A to A and memory, all of these things work. And so with that, I think I am done. You can find all of the information at rockbot.dev. I've, like Sean mentioned, I've done a lot of blogging as I've been going through this process. That's all at blog.lhotka.net. And I'd like to thank you all very much for spending time with me today.